Welcome to SIIMcast, a podcast brought to you by the Society for Imaging Informatics in Medicine.
Greetings, SIIMcast listeners. On this episode, Ali and I had the pleasure of sitting and chatting with Isaac Vetter from Epic. Isaac works on tools and standards that help developers build apps in healthcare. With over a decade of experience within the FHIR community, Isaac leads the CDS Hooks project and is the primary author of the FHIRCast specification, as well as holding elected leadership positions within the HL7 standard development organization. I hope you find this chat as informative as we both did. Isaac, thank you so much for joining us here today. I want to hear you give us a quick introduction about FHIRCast, the kind of problems that it aims to solve, and specifically in imaging if possible.
Yeah, hi, Mohannad. Thanks for having me. So the first thing to understand about FHIRCast is that it's an HL7 specification that enables context synchronization. So context synchronization is just kind of this basic idea that a clinician is using multiple health IT applications at the same time as part of the same workflow. Context synchronization is an interoperability technology that makes all of those different applications kind of show the same clinical content, maybe the same imaging study, the same patient record to that user at the same time. This is particularly relevant within the imaging space because radiologists appropriately have really high expectations that the multiple applications that they're using, that these different tools that they're using work together well and enable kind of their very fast workflows to be successful. So that's context synchronization. So what we've seen over the past couple of years is actually FHIRCast kind of go above and beyond that base functionality for context synchronization to actually begin to kind of experiment and enable with the exchange of imaging findings in real time between these different applications. Within the FHIRCast space, we call that content sharing. And we're seeing that kind of as a result of some of the increased ability of artificial intelligence to find and propose draft findings and, for example, draft image measurements to the radiologist in real time.
This is great. Thank you. I should point out I'm also slightly biased here because I am somebody who's worked his way through the vendor community ranks. And at some point in my professional life, I was actually that guy who worked on those context sharing integrations. And I happened to be in that domain just around the time that FHIRCast came out. And I remember being very excited. I'm like, yes, finally, about time somebody came up with an actual standard that we could all follow. So if I may just add the one thing here, before FHIRCast existed, there technically was a standard that was called, affectionately known as CCAO. But as far as I know, it's pretty much never implemented. And therefore, that context sharing world, at least in the imaging world, was all just Wild West. Every integration was a one-off integration. And FHIRCast was very much needed. So thank you for coming up with that, Isaac. Appreciate it.
Yeah. And Mohannad, I have a very similar experience. So like back in my day job, sometime around 2013 or 2014, I actually started to work on kind of application integration type functionality. And a lot of that was actually coming out of Smart on FHIR initially. So, and then I got to spend some time with like Epic's team that did kind of this application integration type work. And then back then it was crazy how all these disparate, varied vendor-specific technologies that paired some type of single sign-on with context synchronization. I bet you experienced this. I mean, everything from like Microsoft COM APIs to Java Web Start and file system polling. That was kind of the state of the art back then for this really important functionality that radiologists depended upon and needed. And then the CCAL spec, my understanding is that CCAL was actually used for a while, especially like in the aughts, but that it didn't really very successfully make that transition to the web. And as we started to see more Smart on FHIR applications, Smart on FHIR becoming more and more of a thing, enabling more web and mobile applications to work within a clinician's workflow, it became kind of clear that we needed a context synchronization mechanism that enabled web applications and that was a little bit simpler than CCAL.
That's actually a perfect segue into my next question. So you've kind of given me how you started thinking about it, but I'm actually curious, that eureka moment of, hey, let's create a new standard that solves this problem. Can you tell us more about that? And then you also touched very quickly on the evolution of FHIRCast, but I'm curious what the iterations looked like and how that was driven.
Yeah. So back in the day, as we were describing, like we had this really wide variety of all of these different technologies. Every software developer had, their own favorite context synchronization functionality, but then also had to support, half a dozen other synchronization technologies as well. That's a lot of work. I mean, there just comes a lot of burden with that much maintenance. And what it really does is it limits the industry's ability to create new and novel capabilities because there's just so much work to undertake all that maintenance to maintain all of these different integration technologies. In around 2013 or 2014 or so, here at Epic, we began moving our primary user interface client to a web application. So many of these legacy existing content synchronization technologies were based on desktop integrations. Again, things like Microsoft COM or command line shell interactions or file system polling. And none of those are really technologies that really work well with web applications. Additionally, we started to see things like, cardiology PACS systems moving to web applications, such that a lot of these integration technologies just weren't technically feasible. So back then, I really wanted to try to find and ultimately create an industry standard that took all of these different shared capabilities across all of these different vendors and just to find one mechanism that everyone could use such that we could build on top of that one single technology in order to create more advanced capabilities. Context synchronization should be table stakes for the health IT industry. This is important and simple functionality that should be widely available to clinicians, and it's not innovative at this point. Really, what we need to do is, again, build on top of that to create new capabilities like content sharing, like integration with, imaging analysis bots. And FHIRCast has gone through a few iterations, especially at the beginning. Those initial goals were, creating a web technology that was accessible to web applications that didn't have some of the issues that we saw with CCAL around kind of heavy software, expensive. So we wanted to create a simpler and more accessible web-enabled context synchronization standard that used FHIR as that common data exchange model. Initially, we actually started by trying to design FHIRCast using this FHIR subscriptions technology as kind of a pub-sub notification mechanism. It was actually with feedback from Cerner engineers at the time that really encouraged us to kind of switch to model the FHIRCast subscription and notification kind of pattern after a common W3C spec called WebSub. That was FHIRCast kind of version 1. Before we saw any production implementations, notifications were based upon REST hooks. And then over time, as the community of implementers experimented, we really ended up centering on the use of HTTP WebSockets as a primary exchange technology. There are a number of advantages to that, things like speed, but more importantly, with using WebSockets as a kind of a bidirectional persistent connection, there is no need for that FHIRCast subscriber to host a accessible endpoint. This means that, for example, a FHIRCast subscriber could be just a JavaScript application running entirely in the browser without a backend, or even a desktop application that doesn't have a web server on the internet. And those are really important kind of architectural abilities that the use of WebSockets gives us. So then I think that was version 2. So with version 2 of FHIRCast, that was really the version where we began to see initial production implementations start to roll out. Right now, we're almost at the point of publishing FHIRCast version 3, which is really exciting. And really, the state of the specification, the state of the community and project right now is to continue to solidify that context synchronization capability. I think we've mostly got it figured out. And that specification is hardening because we're seeing these production integrations, production implementations and deployment for FHIRCast. And so my goal as a caretaker of this project and specification is to begin to kind of set that context synchronization specification more in stone, to harden it so that the implementer community and ultimately health systems and clinicians can rely upon the stability and functionality that FHIRCast context synchronization provides. So that means a lot of the interesting stuff. I'm always interested in the new stuff, right? The interesting stuff here with FHIRCast is really about this content sharing capability. It's about this exchange of real-time draft findings within clinical workflow between multiple participating applications. And that capability is less mature than context synchronization and also has a much higher ceiling in terms of the value that it can bring and provide to clinicians.
Thank you for that, Isaac. And I'm just learning so much. And then it's just so wonderful to hear about kind of where the idea came from, where we're at now. And so then when I think about, what's next, and we think about some of the demos that we've been doing with, medical imaging specifically, the question comes to mind about, where is FHIRCast in real life? Are there any specific vendor adoption stories, any product implementations that you can tell us about, or even experiences at Connectathons, trying to see what the role is and what some of the barriers may be for its adoption? I know that's a lot of questions, so.
Yeah, thanks, Ali. I also just want to maybe provide a slight caveat that I don't always have a great sense of what all of the different vendors in the space are doing. For example, Nuance has their PowerCast product that they announced, quite a while ago, 4-5 years, something like that. And I'm not really sure of the extent to which that product has been deployed. I have the best insight into Epic and Epic's customers' usage of FHIRCast. So, but from my perspective, we're kind of at that initial production deployments at scale step. There's kind of a smaller number of software products, a smaller number of health IT applications, and health IT vendors are kind of rolling out FHIRCast integrations at scale. So I actually just checked the Epic deployment numbers for some FHIRCast integrations, and Epic only has 500 and some customers. 380 of those organizations are using Epic's FHIRCast hub in some way. And so maybe that doesn't sound like a lot, but a pretty good number of health systems, at least within the US, are using FHIRCast, but only in 1 or 2 cases for really specific purposes and integrations. I think that's an accurate picture of where we're seeing, FHIRCast adoption and its level. I think we're almost to that tipping point where, of course, new vendors, new applications that need context synchronization will, of course, develop support for FHIRCast as a FHIRCast subscriber. It will save them the cost and effort of supporting disparate vendor-specific integration technologies. And hopefully over time, it'll even become the easiest path for them to take, in addition to the kind of the most efficient and the most capable.
Maybe I can add something here. So Isaac, thank you for pointing that out. That's actually really cool to know that, that's more than half your deployments, actually almost 2/3 using it. I will also say, with my host hat off for just a moment, as somebody who's involved in imaging informatics quite a bit, in my mind, I see enough vendors having FHIRCast implementations, whether they use them in production or they're just for prototype, but it's still, in my opinion, there's no question that it's reached critical mass. It's definitely here. And if you've not implemented FHIRCast, you're 100% missing out. I will also say that FHIRCast has been adopted so fast, probably faster than pretty much anything new that's come out in recent memory. And it's not to say that, the others are no good, but I think just FHIRCast came at a time that was so needed and it solved such an important problem that it was almost a no-brainer for everybody or most people to jump on it. So kudos to you and the team one more time for this work. It's really helpful.
Thank you. That's great to hear.
Isaac, I don't know if you're at liberty to talk about this, but I'm actually curious. Are you able to give us some insights into FHIRcast's roadmap? What else do you have on your radar screen?
Yeah, definitely. And I can definitely talk about this just from the industry project perspective and from the, HL7 standard perspective. One of the things that, I maybe mentioned earlier, one of my goals over the next, year, 2 years is to start to really solidify that context synchronization capability. So my plans, and I'm also a co-chair of the infrastructure and messaging work group within HL7, and which is the work group that is primarily responsible for this HL7 spec. Our goals there are to look at making the actual HL7 FHIR specification normative for the parts of the spec around context synchronization. Again, to kind of communicate to the industry, to the community, that they can rely upon this content. They can rely upon the specification. It's not going to change underneath them. We're not going to introduce significant new breaking compatibility changes over time. So I think that that's kind of one of the important capabilities. And then the second is really just continued effort and work to enable that content sharing. So we've been experimenting a lot with that. I think as an industry over the last 18 months, I think this next publication version of the specification will reflect that. And so that increased maturity in the ability to generate and share those draft clinical findings. But the third part that I think is really important, and this one kind of been one of my goals from the beginning with FHIRcast, is that context synchronization is not relevant to only radiology applications or cardiology, not only to imaging applications. It's just super important within that space because of the high expectations of our clinicians. Every smart on FHIR application that can't fit within an EHR iframe can benefit from context synchronization. It's easy because imaging is so important here. It's easy for us to focus only on imaging, but my goal for FHIRcast is to also be accessible and generally available to just every single type of smart on FHIR application that's provider facing that again doesn't fit in that iframe. I think some of the good examples that I've run across over the years are, saw one integration with a digital fetal monitoring strip. And the interesting part about that is that fetal monitoring strips, they are like, just from a user experience, a UI perspective, they're horizontal bars. And it doesn't fit into any kind of EHR iframe, standard iframe capability that I've seen across the industry, across all the different EHRs. And so that integration, a clinician who's working within their EHR and also, watching this fetal monitoring strip as it kind of graphs out information about the fetus over time, that fetal monitoring strip, a web application or application, kind of is sitting on the clinician's desktop. And when the clinician switches between patients' charts within their EHR, they want that monitoring strip to appropriately close or also switch context. And so that's a obvious use case for context synchronization technologies, and generally kind of unrelated, not what we'd think of as kind of the traditional imaging tech. FHIRcast should also be accessible to just these kind of common smart on FHIR applications that are provider facing.
Thank you, Isaac. And not to switch gears too hard here, but I figured, we have you on the call here with SIIMcast. We've behind the scenes been working a lot with something called CDS hooks. And I like to talk about it at every opportunity because I think it's absolutely amazing that we are looking at applications for CDS hooks in medical imaging. So I like to share that with our audience, and I'd like to pick your brain a little more since we have that opportunity. Can you tell us more about what CDS hooks is and maybe a couple of examples of some of the really exciting cutting edge use cases that you know of or that you recommend?
Definitely. So CDS hooks CDS stands for Clinical Decision Support Hooks. It's, again, another HL7 standard that defines how a remote provider-facing real-time clinical decision support service can interact and inject that decision support, that guidance into clinical workflows, typically within an EHR, but not necessarily. So related to imaging, kind of the classic example of remote real-time CDS is actually a requirement from the Protecting Access to Medicare Act, so abbreviated as PAMA. So that PAMA Act has introduced a CMS requirement that an ordering clinician is required to consult with an approved decision support service for appropriateness before placing particular expensive orders. That is one of the kind of driving use cases. Again, it's a regulatory use case. I don't know how exciting it is, but it's one of the use cases that we're seeing that's kind of driving adoption of kind of the standard way for an EHR to access this external CDS service in real time to provide guidance to the clinician. CDS Hooks actually provides a number of different ways in which that external service can interact within the workflow in real time. So we call them cards. So a CDS service returns, one of a couple different types of cards that are then presented by the EHR within that clinician's UI. The first type of card that CDS service can return is just kind of simple markup. Here's instructing or informing the clinician through mere text or images, tables, to help them kind of make a clinical decision. The second type of information that can be returned as a card is actually a link to a Smart on FHIR app. So a suggestion might be, hey, clinician, I see that you're interacting with a patient's chart with this particular condition. Here's a nice visualization app that, can help share decision-making between you and the patient in this appointment that you're conducting right now. And then the third capability of a CDS Hooks card is actually to return what we call suggestions. And so a suggestion is a discrete recommendation for the clinician to modify, for example, the dose or the particular medication that they're in the process of prescribing. And because we use FHIR to interoperably represent that clinical content, the order, that prescription, the EHRs have the ability to take and understand that discrete suggestion from the remote CDS service and make it really easy for the clinician to take that advice, to take that suggestion, to implement that suggestion, often through just kind of clicking one button. So that's kind of a big picture. That's what CDS Hooks is. I think some of the more interesting and novel use cases that we're seeing are actually things that you might not traditionally think of as clinical decision support at all. Another one of the kind of driving use cases for CDS Hooks is actually around electronic medical prior authorization. Within the HL7 space, within the FHIR space, there's a corollary specification to CDS Hooks. It's called Coverage Requirements Discovery. This is kind of written and funded by the HL7 Da Vinci FHIR Accelerator, which is a group of payers and providers kind of working together. And that coverage requirements discovery functionality uses CDS Hooks to actually enable payers and other kind of payer software developers to return information ultimately about prior auth, about what is it, here's a procedure that a clinician is in the process of ordering. The clinician's EHR can reach out in real time to that payer, to a payer system, to get information about whether or not that procedure will be covered and what are the requirements to cover that procedure. Medical prior auth in the US is a very, very large problem. And so it's really exciting to see the industry and CMS kind of support more novel technologies that can hopefully help address that problem for clinicians and patients.
Thank you, Isaac. That was a very nice introduction to CDS Hooks. And again, with my host hat off for just a moment, I get so excited about this stuff. I feel like this stuff is just not happening fast enough. Not in the sense that, people who are creating the standards are not working fast enough. It's just, adoption in real life. You touched on a number of applications for CDS hooks. I'm actually curious, being an expert in the field and you're involved in some of these implementations in real life. I'm actually curious to hear, in no particular order, some of your favorite applications you've seen. So you just mentioned the pre-authorization workflow. What other cool use cases have you seen, both in imaging and outside of imaging?
Yeah. And that prior auth is a giant problem. I'm really excited about seeing that one. And to the extent that CDS hooks can make a difference there, I think that's going to be really great. There's also kind of related integrations between payers and providers. There's also some interesting uses of CDS hooks there. For example, I've seen some integrations where, as part of a value-based care arrangement between a provider and a payer, providers are responsible for kind of maintaining a hierarchical condition categories diagnosis. So HCC codes on specific diagnosis for their patients, the patients they're responsible for, again, in a value-based care arrangement. And that HCC code kind of documents the severity of illness for that patient and ultimately impacts reimbursement as part of that arrangement. So for example, this is, how Medicare uses HCC codes. So we've seen some payers can help suggest via CDS hooks particular HCC code diagnoses in real time when the clinician is interacting with that patient's chart. I think ultimately, like, CDS hooks is really good anytime there's an external source of data to the EHR that is used to drive clinical guidance, that is used to drive clinical decision support. Sometimes that takes a few different forms. For example, the payer has this big old source of data, of all kinds of data relative to the patient that may not be accessible to the provider system, in which case we can use some of that guidance to deliver useful and valuable decision support within the clinician's workflow. I think a second category of use cases for CDS hooks is maybe instead of having a bunch of data external to the provider system, sometimes it's just guidelines for kind of, care paths for clinical best practices. If they change over time, sometimes clinical guidelines will change really rapidly. I've seen a number of vendors use CDS hooks as a way to access their own system that encodes those clinical guidelines to enable that provider organization to not have to do it themselves. I think those are kind of two general patterns for when CDS hooks does make sense. And then I also just want to say, lastly, one of the initial use cases, the origin story for CDS hooks is actually that David McCauley, who was a kind of a titan of health IT interoperability over the last couple of decades, from Cerner, and just retired a few years ago. Once we were starting to see kind of more and more deployment of smart apps in like the mid and late teens, he identified the problem that, well, now that we've got all these smart apps, right? How the heck does a provider find them? They're just kind of buried in this menu within my EHR somewhere. And obviously, like, clinical workflow integration of Smart on FHIR apps requires some creativity. It is a problem. If a clinician doesn't know that they've got this, visualization application or this guideline recommendation application available to them, they're not going to use it. And sometimes even then they won't use it. That power, that ability, that capability of CDS hooks to surface and recommend the use of a Smart on FHIR application within the clinician's workflow is a really powerful capability that we're only just kind of starting to see be used and be exercised to its full capabilities.
Isaac, I think that the Smart on FHIR app, you and I have actually talked about this, and the more I think about it, it's quite exciting. Just for our audience, though, can you tell us what is a Smart on FHIR app, and just maybe a use case or two? I know we've talked about a few, and we have some really exciting work spoiler alert coming down the line later this year. But can you tell us just briefly what is a Smart on Fire app and maybe a use case or two that best exemplifies it?
Yeah, definitely. Smart on Fire. SMART is actually an acronym, a backronym. Substitutable medical apps and reusable technology, I think. It was initially a result of some research in, I don't know, 2010 or so from a ONC Sharp grant out of Boston Children's Hospital, where the idea was, hey, we're going to create apps for healthcare, just like, the iPhone was a big hit at the time. And this idea that, we should have apps that we can just kind of plug in that patients can use to access their data, that, providers can use to supplement kind of their workflow. And so Smart over time eventually became kind of the de facto security and authorization and technology in which web applications could be made available and can access clinical data using the FHIR standard, both for patients and for providers. So Apple Health is the stereotypical example of a Smart on Fire application that a patient can use to access health data using FHIR from their health system. So the patient authenticates to the health system's patient portal and selects the data that they want to share with this external Smart on Fire application, this external web app. And then the patient authorizes that web application to access FHIR APIs on their behalf. From a provider perspective, the same kind of technology and process can be used from a provider perspective as well. However, instead of logging into the EHR, what we typically see for provider-facing Smart on Fire applications is that the provider can launch a third-party Smart app from within their EHR workflow, for example. What are examples of Smart on Fire apps for providers? I think, again, I mentioned this earlier, but I think a really great example, a really great category of Smart on Fire application is, shared decision-making visualization applications. The University of Utah has spent a bunch of time, for example, on a bilirubin application that graphs, newborn bilirubin lab levels against kind of the published guidelines in order to really kind of quickly give a visual indication to a clinician of the possibility of jaundice. Kind of a similar category is actually MD Calc. So, the clinicians, like MD Calc is a commonly used library of clinical calculators that's just kind of available on the internet. Folks at MD Calc have actually started working to enable specific clinical calculators to be accessible as smart apps and such that they can be embedded within that clinical workflow to, save the clinician a couple of clicks. And so that visualization capability is a really common pattern for Smart on Fire applications. How was that, Ali? Was that a good introduction, or what other information there should we provide?
That was perfect. You actually read my mind because my next question was, who's the consumer, right? Is this a patient-facing or provider-facing use case and tool? And I think you addressed both of them. So thank you. And let me just say again, I'll copy Mohannad here. Host hat off. I can't wait to see some of this in practice and then some of the demonstrations that we have upcoming too. So, okay, host hat back on again.
I need to interject here for a moment because just before Isaac answered this, Ali, you left us on a cliffhanger. You said something about exciting work coming out next year. I need to hear more about that, please.
I thought you'd never ask. So, Isaac, feel free to jump in any time too, but we have some exciting demonstrations coming up. Collaborations ongoing, right, with RSNA and the Radiology Reimagined demonstrations, where we hope to show the role for CDS hooks, not just in radiology workflow, but really in bringing imaging findings to the clinical workflow. So I don't want to give away too much there, but I know we're looking at several use cases, right? Recommendations for incidental pulmonary nodule identification, potentially incorporating a Smart on Fire app, looking at linking drug toxicities with imaging findings and ensuring a timely notification of those findings to ordering team, the clinical providers. So again, not to give away too much, but I think we have some really exciting use cases that show the versatility, the flexibility of CDS hooks in radiology specifically. Isaac, what do you think? Is that enough of a teaser to
I thought that
invite?
was great. And I mean, and there's a lot of capability within the space, within imaging, in order to kind of deliver more value to the clinician. And I'm optimistic and excited as we kind of start to explore more of that within RSNA and within SIM, that we'll really have some great outcomes for both radiologists and ordering clinicians within imaging.
And I hate to say it, but it looks like we're running out of time. Time really flies. So before we get to our last thoughts, Isaac, what is the future roadmap for CDS hooks? What's next?
Yeah, right. Kind of similar to like the FHIRCast path. One of my goals is actually to try to, again, reach specification, stability and maturity in that formal way by starting to make some of the CDS hook specification normative within that HL7 process. But I think one of the important focuses of the CDS hooks community, of the CDS hooks project team within the industry right now, is actually around performance. If you really think about it, there's relatively few health IT interoperability standards that inject a third party into clinical workflow so directly as CDS hooks. So like, again, unlike, hunting through that menu for a Smart on Fire application, or if you think about things like, patient summary, backend interoperability, like what we typically think of as interoperability, the exchange of patient summaries through this, backend system network, like a Carry Quality or TEPCA. CDS hooks is kind of in your face. And that is both a great power for CDS service developers, but also it introduces more and more responsibility. So the responsibility for a really excellent clinical user experience is now shared between that clinical workflow system like an EHR and this external CDS service developer. Once that service developer's card CDS service output is integrated into the clinical workflow, we should expect that use of their decision support will be much higher than if they were just delivering that decision support in kind of other traditional ways, including potentially it'll be used by providers that don't want to interact, that don't want or need that CDS, intervention. So CDS service developers should be prepared for higher scrutiny, that higher expectation of performance and quality. The bar is higher here in general. So as a result of that, one of the things that we're seeing is that the CDS service needs to return its guidance as fast as possible. And the EHR needs to kind of display, if that guidance is being displayed, needs to display that guidance as fast as possible. We can't hold up the clinician's workflow in order to, return this CDS guidance. There's a couple of ways in which the CDS Hooks project is kind of helping to enable that service to respond faster and to get that CDS in front of the clinician without holding up their workflow. And the technical capability is actually called prefetch. So when a EHR, makes a request for clinical decision support from this remote service, one of the CDS Hooks capabilities as part of that request is that the EHR can provide some relevant FHIR resources ahead of time to that external service. So that external service can run through its, decision support algorithms, run through its AI or whatever it is, and without having to make API calls back to the EHR in order to get the data to run through those algorithms. And so the types of data that can be provided as part of that, prefetch and are currently a little bit limited based upon how a CDS service can describe the information that they want prefetched, that they're requesting to be prefetched. And so that's actually going to be a big focus over the next 6 months or so, 9 months or so. as we try to figure out how can we help CDS developers, CDS services get access to the clinical information that they need to run their algorithms in an even faster and kind of speedier way.
Isaac, this has been a great conversation. I really appreciate your time here explaining all these different concepts to us and our listeners. Unfortunately, we're running out of time, so I want to ask you our last question for today, and it's a multi-part question. So the first part of the question is if you have any other thoughts of something that you wanted to cover. And then, of course, the second part is if you can tell our listeners where they can go and learn more about any of the concepts you talked about, like FHIRCast, CDS Hook, Smart on FHIR, and how people can be involved if they perhaps want to be able to contribute to these movements.
Yeah, definitely. If you work within a health system, I would say understand what your health system's kind of software's capability for supporting some of these standards. We're seeing kind of gradual growth and support of CDS hooks within kind of different EHR software. And then there's lots of information and there's kind of robust communities around both the FHIRcast and CDS hooks projects. FHIRcast.org, cdshooks.org, both are kind of community-facing websites that are intended to help be on-ramps to kind of just learn more about these two projects and specifications. We also periodically, as part of the HL7 FHIR community, hold FHIR Connect-a-thons around these technologies. We'll also see some FHIRcast work at the SIIM hackathon later this summer. I think Ali kind of gave us an overview of maybe some of the things we might see at the RSNA event later this year, I think in December. There's also just the FHIR community in general also has this incredibly robust chat server at chat.phir.org. Kind of think of it like a Slack, where just leaders of the FHIR community, really expert, knowledgeable people are very willing to kind of share their experience, to give feedback, to answer questions about FHIR in general, including FHIRcast and CDS hooks. And then lastly, depending upon your level of tolerance for standards calls and standards work, both of these two projects are kind of governed and sponsored by specific committees, specific working groups within the HL7 Standards Development Organization. So the Clinical Decision Support Work Group is responsible for CDS hooks. We have weekly calls where we deal with kind of the management and governance of the specification and project. And then similarly, FHIRcast has a corresponding infrastructure and messaging work group. Also, we have weekly FHIRcast calls as well. And you can see more about those specific calls at hl7.com/concalls. There's lots of opportunity. We're a growing community. We really want and encourage your participation and your interest, even if it's anything from just asking a question to kind of helping to write some of these specifications.
That is awesome. Once again, thank you so much for your time. Really appreciate you being here with us, patiently explaining all these concepts. It's hopefully something that's going to be very useful for everybody listening to this episode. Thanks again.
SIIMcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at SIIM.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.